Hi, welcome back to this channel. In this video, we're going to discuss tutorial question number 3 until number 6. Let's start with question number 3. Natural rubber is the polymer made up from the repeating unit isoprene. Give the IUPAC name. So CH2 double bond, CH, and then CH3 double bond, CH2. So the longest carbon chain consists of 1 carbon, 2 carbon, 3 carbon, and 4 carbon. So double bond is at the carbon 1 and carbon 3. So it will known as 1,3-butadiene. And then there is one substitute at second carbon. So 2-methyl-1,3-butadiene. Question B, write an equation for the formation of the natural rubber. Since we already have the monomer, so let's start with CH2 double bond, CH3, and then double bond CH2. As we know, for this alkene, they will undergo addition polymerization by breaking down the double bond. So 1 electron over here, 1 electron over here, and then this one is 1 here, and then another 1 here. So end up we have the structure CH2 double bond will become single bond, and then CH single bond become double bond, CH3 double bond become single bond CH2. So here we will end up and then make the bracket and then put the N. So therefore, to make the balance equation, so here at the monomer here we also put the N. Okay, then next we continue with question C. Name the type of polymerization, which is the addition polymerization. Okay, and then question number D. Type of polymer. So you can mention it is homopolymer because it only have one type of the monomer, which is the isopropene. Proceed with question E. Natural rubber is not suitable to make tire. Explain the answer. Okay, because this polymer chain, it is natural, and then which is the straight chain, so it's easier to pass by each other, can slip past each other. So to make this polymer become stronger, we can suggest a process which is vulcanization. Okay, means cross-link rubber which add in the sulfur. So and then the next one G, neoprene is the synthetic rubber made by the polymerizing chloroprene. Write an IUPAC name for the chloroprene. So let's draw the structure. CH2 double bond, CCl, CH and CH2. So 1, 2, 3, 4 also have 4 carbon, and then the double bond is at carbon 1 and carbon 3. So but this time the substitute is the Cl. So in this case, I think we will number the carbon from the left to the right so that the substitute has the lower number. So this one we will known as 2-chloro, still 1,3-butadiene. Okay, then next we have to draw the structural formula for the repeating unit. So means that we just try to open the double bond. Okay, then we will get the structure CH2 have a hanging bond, double bond becomes single bond, CCl, single bond become double bond, CH, and then the double bond becomes single bond, CH2. So because this is the repeating unit, so we no need to put small n after the structure. Okay, proceed to question number 4. These are the reaction scheme that to show polymer X prepared from compound A. So now we need to suggest the reagent and condition for the conversion of 1, 2, and 3. So 1, 2, 3 is over here. 1, 2, and 3. Okay, so let's start with conversion of 1 first. So here we can see Br bromine is replaced by the Cn. So that means we can recall to the chapter of haloalkane, where means we are going to react with the KCN in ethanol and then reflux. Okay, so for second one, we have the functional group nitrile CN. And then here we can see CH2 in the bracket of 2, but here we have 4. So basically, and we know that nitrile always only can undergo 2 reactions. So this one CH2 and H2, so means that we adding the H2 and after the carbon and nitrogen. So this one is known as reduction. So if reduction, we're going to use lithium aluminum hydride in dry ether and then followed by hydrolysis. So, and then another reaction that will be carried out by nitrile, from nitrile change to COOH. So means that we know this is the hydrolysis. So if hydrolysis, we are going to use H2O, H3O plus. Okay, then now let's proceed to B. Name the compound A. So compound A here we have 1 carbon, 2, 3, 4. So it's 1,4 dibromobutane. Okay, and then we have to name the structure. Sorry, we highlight here compound A, compound B, and also polymer X. So the compound B also consists of 6 carbon. So from here we can see 1 carbon, 4, so 5 and 6. So this one, the carboxyl group is at the both terminal, so it will known as 1,6-hexane di. Sorry, 1,6-hexane dicarboxylic acid. Okay, sorry, I think this one here, the B basically is referred to this structure because like A, they are referring to this structure. So if this is a B is referring to this structure, so this structure will known as 1,6-hexane diamine. Okay, so next one is the polymer X. So this polymer X basically is nylon 66. Okay, this polymer X is the nylon 66. Okay, so next one we are going to get the structure for the repeating unit of the polymer X. So how to get this polymer X? Basically is the amine react with the carboxyl group. So let's start with the part of the amine. So we will have CH2 and H. Okay, and then connect with CH2 because here we have 1 CH2 and then here 4, 5, 6. So CH2 bracket 6 continue with NH, and then for the carboxylic acid we will break down the bond over here, so we'll be connected to C double bond O, CH2 bracket 4 and then C double bond O. So since we want the repeating unit, so you no need to put N at the bottom, at the back here. So last question D, state the use of the polymer X. So polymer X will be used to make parachute and ropes because it is a strong material. Proceed to question number 5. C10H14 oxidize with acidified CmNO4 to form B aromatic dicarboxylic acid and then react with methanol to form ester. So from here, I think the keywords for here to start will be the structure B aromatic dicarboxylic acid. So as we know, aromatic means that the structure basically contain a benzene ring, and then they will have two carboxyl group. So because of we are doing the chapter polymer, so basically normally they will at the opposite side. Okay, then we know that benzene cannot undergo oxidation, but alkyl benzene able to undergo oxidation. So, however, also not all alkyl benzene can undergo oxidation. Only alkyl benzene with benzylic hydrogen going to undergo oxidation. So from here we know that altogether the compound A consists of 10 carbon. Benzene ring only have 6 carbon, so that means they are extra 4 carbon. So means that both side of the alkyl group basically will have 2 carbon. So and then we can check the number of carbon, definitely is already 10. And then number of hydrogen, 3 plus 2, 5. 5 plus another 5 over here, 10, 11, 12, 13, 14. So fulfill the question C10H14. Okay, then we also know that here we have the benzylic hydrogen, so we're able to form undergo oxidation to form aromatic dicarboxylic acid. Okay, then next will to predict the structure C, the B will going to react with the methanol. So this is the structure for methanol, CH3OH. So for the carboxylic acid, as we know, it will break the bond between C and OH, while for the methanol is between O and H. So now let's start with the structure C. So we will have the benzene ring. Okay. And then C double bond O, C double bond O. Then we'll connect it to OCH3 and here also OCH3. So after we done for the question A, then now we will continue with the question question B. So how C can be used in the formation of dacron. Okay, so as we know, we have this structure. Okay, dacron is called polymer. So one of the monomer is the one that we just write that over here, CH3O, C double bond O, benzene ring, and then C double bond O, OCH3. So another monomer is the diol, which is CH2OH, CH2OH. So with this, basically, we want to show the chemical equation. So the bond will break between, for this one, ester, it will break between the carbon and the oxygen over here, and then for this one they will break at here. So we will has bonded to C double bond O, and then break the bond. So we have a benzene ring connected to C double bond O, and then from here, this one here, we will have another one, which will be CH2, CH2, and then connected to the O. So since here we want to form the polymer, so we have to have a small n over here, and then in front here we also add in the small n over here. Okay, so this will be the answer for question B. So question B is done. So now next we go to question C. So question C, they ask us what is the type of polymerization. So because we are combining two monomer with eliminate. So this one is the condensation polymerization. Okay, so I think I make a mistake over at the up here. Since we are writing the equation, so they will eliminate the CH3O and the H from the alcohol here. So we must have plus NCH3OH. Okay, last question in this video, question number 6. Cordial, a polymer made from the following monomer and then used to make fiber for weaving crease-resistant fabric. Write an equation for the reaction between both compound above. So we skip question A first. Let's continue with question B because B, C, D, E give us a straightforward answer or short answer. Name the functional group of the polymer form. Since we can see here we have carboxyl group and then we have hydroxyl group. So the functional group for this polymer, they will become polyester. But this question is focused on the functional group. So it will be carboalkoxy. Okay, and then they ask us to write the repeating unit. So basically, like we know previously, for the for the carboxyl group will break the bond between carbon and OH, while for the alcohol will break between O and H. So this case also happened. So let's draw the structure. So in this case, then the repeating unit will be benzene ring connected with C double bond O, and then this one also C double bond O hanging bond, and then connected to the O, H2C connected here, and then CH2O. Okay, so this is the repeating unit. Do remember that don't put the N after the structure. Next one, you are asked to give the general name for this polymer. So because we have the carboalkoxy, so the general name for this polymer will be polyester. And then the question asks us the type of polymerization. So since we know that the bond break between OH and also H, they will going to form H2O. Means the elimination is happened. So this is the condensation polymerization. Okay, now we do the tutorial question 6a. So write an equation for above. So I think basically just now we already discussed about here. The bond will break between carbon and OH and also between O and H. So I will put N and then we draw the structure. C double bond O, benzene ring, and then connected with C double bond O, OH, plus the alcohol, also N more, O, H2C, CH2OH, and then the product form, just like the repeating unit above just now, C double bond O hanging, benzene ring, connected to C double bond O, so here we'll connected to OH2C band cyclohexane CH2O, and then since this is the polymer, there will be a small n. So from here again, we will eliminate the OH and H to form water, so NH2O. Okay, so I think that's all for this video. We will continue objective question for next video. See you. Bye bye.